Good morning. John Gilkison, Aero Stealth here. I wanted to shoot this video this morning on the road load graph and charts for this 2019 Chevrolet Bolt. Today is Monday, December 6th, 2021. And this has been a long-term project. My friend in Texas, Phil Knox, our aerodynamicist, has been working on a road load graph for the Chevrolet Bolt. The Chevrolet Bolt has a drag coefficient of 0.308 and a frontal area of 25.7 square feet. You multiply those two together and you get the coefficient of drag area. And this graph basically shows up the left side, up this side right here, you have the kilowatts of power it takes to pull the shape of the bolt and tires through the air, and down at the bottom you have the speeds. So for example, here at 100 miles per hour, which the Chevrolet Bolt won't do, it takes 47.27 horsepower or kilowatts to do that in power. That works out to about 63 horsepower. And the at more normal speeds, let's say 65 miles per hour, takes 15.62 kilowatts, which is around 20 horsepower. Big difference. But what you have to understand about this graph is that it's abstracted from the real world. In other words, we're just talking about the shape, the aerodynamic shape of this vehicle with this mass, with its weight, around 3,800 pounds, and the tires that are on it. So what is the rolling resistance of the tires, and what's the aerodynamic drag at various speeds? And at the bottom of the graph, in the blue, is the rolling resistance of the tires. And that, of course, is a linear function. But as you can see, aerodynamic drag is not. It's a cubic function, and it goes up rapidly the faster you go, especially for a higher drag shape. The Bolt, as I said, has a drag coefficient of 0.308. And let's say a new Tesla is 0.23. So this is part of the reason for Tesla's performance at highway speeds is much better than most other legacy car makers, is because they're not paying this penalty right here. Okay? Now, what I wanted to do was make a set of charts that showed the performance of the Chevy Bolt at speeds. And I just chose the speeds 35 miles per hour through 90 miles per hour because those are the speeds we're most likely to do. And so it's kind of like a projection. In other words, you're saying, well, I'm going to take a trip somewhere and I'm going to be doing 65 miles per hour. And it tells you right away that with a 60 kilowatt hour battery back, you're going to have 201 miles of range at that speed. Now, again, this is for flat ground, sea level, 60 degrees of temperature, and so forth. There's a set of conditions here. Now, it so happens that we live here at 4,000 feet of elevation in the desert southwest. So our numbers are slightly higher. So I had to watch out for that bias in my graph. And one of the places I came out as a reference, as a check on my work, was that at roughly 62 miles per hour, I have about 220 miles of range. And again, you got to realize I'm only using 90% of the battery here because you're not going to drive your car from 100% down to zero. At least most people aren't. You're you're going to use, and when you get down to 10% of battery, you're going to be looking for a charger. So, and then the same thing with the 65 kilowatt hour battery pack. I'm assuming you're only using 90% of your battery. So what I'm telling you here is if you do these speeds at 65 miles per hour example that I gave here, for a 60 kilowatt hour battery pack, you're taking 3 hours and 6 minutes at that power consumption, which is 17.40 kilowatts, to do 201 miles of range. Now the time is slightly higher, of course, for a 65 kilowatt hour battery pack. But the important thing here is we've derived this number, 17.40 for 65 miles per hour. If you look on this chart over here, it's 15.62. But you got to realize we got driveline losses. So I've estimated power losses from drive lines that I use a multiplier of 1.05, and then I am adding 1 kilowatt for my standby losses, which is what my car tells me it's doing when it's parked. And that's how you come up with this new figure. And so at 65 miles per hour, it says I'd be getting 3.7 miles per kilowatt hour, and I'd have 112 mpge, which is pretty much dead nuts on for the combined rating, I think, for the Chevy Bolt. So what I ended up doing was these two charts here was made into a laminated card that's like 3x5, and you could throw it in your glove box. And I liked this graph so much that I made a card up of it. And amazingly enough, it turned out that you can read it and everything, even though it's much reduced. It's very legible. And on the back side, I have this chart over here. And it's would make a good Christmas tree ornament. It's very colorful. But what prompted a lot of this work was this original card right here, which was prompted by the fact that the readout on the dash of the car is in miles per kilowatt hour. And that's fine. You get used to it after a while, and you know, well, oh, I'm performing well, or hey, I'm really not that efficient today in my driving. But most of us would have to stop and do mathematics to figure out what our miles per gallon was, what our range was, and all this. And so originally I came up with a card based on these two charts here, which is, again, about a 3.5 by 5, and you throw it in your glove box. And when you're driving down the road and you see, well, I'm getting 4.2, right here it is, 4.2 miles per kilowatt hour, means I'm using 238 watt hours per mile. And at 90% charging efficiency, I'm getting 127 miles per gallon. And if I'm using 120 volts and I'm only at 80% charging efficiency, I'm getting 113 miles per gallon. So all this information is available to you. And I think it's kind of an eye-opener. People don't realize what they're losing when they're using the charger that comes with the car. If they don't get a 240 volt charger, they're losing money and efficiency. So that's my 3 cards, and that's what I wanted to talk to you about today. I have more to do on aerodynamics and charts, but I want to keep it separate from this video. I just wanted you to see this road load diagram and chart and graph I meant, and the charts that I carded up here. So anyway, this is the new set of cards we've produced with all this information on it right here. And I like it. I think it is useful, and I may make more of them up someday and use them as giveaways or sell them. We just have yet to figure out a way to do that. Let's see, any more information on here? Yes. The CDA of our car is 7.967. And the EPA test weight is 3,880 pounds. So, straight, level, dry, calm, sea level, constant velocity. So there you have it. Aero Stealth signing out here. Happy trails, everyone. And slip through that air as if it wasn't even there. That's how I came up with the name Aero Stealth, by the way, because it seems like aerodynamics is invisible to most people. So it's hiding in plain sight. So I use that as my moniker on Echo Motor, as I call myself Aero Stealth. So Merry Christmas, everybody. Bye-bye.